We're ready to start number 19 on the bottom of page 3 on the chapter 4 practice test. So there's two terms. Remember the rules. First, you have to look for a GCF. If there isn't one, then you move on to a difference of squares. And if there isn't one of those, then the third thing you check is cubes. And remember, cubes can be plus or minus, a sum or difference. So start with GCF. Anything common? They're both even. That means 2 is common. So I pull out a 2. And when I divide both of these by 2, I get x to the 4th minus 81. So that was GCF. And we never stop on the first step, especially if we have exponents. So we've already done GCF. There's nothing common, so we're done with that. Difference of squares. Well, it is a difference. Are these both squares? So squares have even exponents. Yes. And this is 9 times 9. So bingo. Now we have a difference of squares. So the 2 stays there. And remember, for a difference of squares, the signs are always going to be different because it's minus. So the only way to get a negative is a positive times a negative. So we have a plus and we have a minus. And for difference of squares, remember, we do square roots. Square root of x to the 4th, 4 divided by 2 is x squared in both the first slots. Square root of 81 is 9. Again, I have exponents. I need to keep looking. I don't stop until I have no exponents. Like up here, we could stop because this was a difference. This was a square, but this wasn't. This is a difference. This is a square, but this isn't. The squares, by the way, are 1, 4, 9, 16, 25, 36, 49. Let's go to 100. So that's 7 times 7, 8 times 8, 64, 9 times 9, 81. So that's the first group of perfect squares. So those are the kind of numbers we're looking for. So that's not a difference. Yes, they're squares, but not a difference. So that definitely can't factor. So the 2 comes down. The second one can't factor because it's a sum. And we need a difference of squares. But look at this. Bingo! So we actually have one on the test that factors twice. Well, this is a paper pencil test, so hopefully I can find one like it in Alex. So difference of squares, again, just like the pattern, we do 1 plus and 1 minus. Square root of x squared is x, square root of 9 is 3. So that would be my answer. So doesn't factor, no exponents, no GCF. So that's how we know we're done. So don't stop until you've checked every factor to see if it factors again. So this one was squares, and so was this. So 3 different factoring. First GCF, then difference of squares, then difference of squares again. Okay, let's go ahead and look at the next page. That one, by the way, would be a good one to highlight. A lot of students miss that one, just like 14. So let's highlight that one at 14 to make sure you go back and look at those later. Okay. Now on page 4, our directions are changing. Now they say solve. That doesn't mean they want parentheses for their answer with factors inside. They want actual solutions. They want numbers. This will have two solutions. This will have two solutions. This is going to be 4x squared, so it will also have two solutions. So if you remember from 4.8, the very first step is set the equation equal to 0. Done. Step 2 is decide the factoring pattern. Well, this is a trinomial with leading coefficient 1, so that means this is double bubble. And remember, keep that 0 so you don't accidentally bring that down and write it for an answer. This is solve. So you might want to highlight that to remind yourself you're solving this. So signs are different. Largest one negative. So we're looking for, let's put our x's in, let's put our different signs in. We're looking for factors of 10 that subtract to 3. I'm thinking 2 and 5. There's only two sets, 1 and 10, 2 and 5. That subtracts to 3. Bingo! Now we just have to figure out our signs. The larger number needs to be negative. That means the smaller number is positive. So we put our plus 2 minus 5. Now if the direction said factor, like all the two previous pages, we'd stop. This is factored. But this says solve. So when we're solving, we have to use the zero product property that says if A times B equals 0, either A is 0 or B is 0. So solve those two, and it looks like we're getting -2 for the first solution. And remember, whenever there's more than one solution, we put them in solution sets. And add 5, it looks like 5 is our second solution. So that is solving, how you leave an answer with a solution set with the same number of solutions as the highest power. 21 says, what are the x-intercepts for that problem? Well, we learned x-intercepts mean make y 0. So when x is -2, y is 0. When x is 5, y is 0. So those are the x-intercepts, and we wrote them as ordered pairs. So you might want to write your reminder. Whenever we have x-intercepts, we take our two x values and pair them with y. So this is where the parabola, which cups up, this is where it's going to cross the x-axis at -2, 0 and at 5, 0. And we know it cups up because the leading coefficient's positive. We don't know this point yet. We learned that in chapter 7, but we do know this much. Cool, huh? So your solutions are actually x-intercepts. These are the x values. X equals, x equals. And we know on x-intercepts from previous work that y is always 0, so we just put a 0 with each one. And they have to be written as ordered pairs. Okay. Let's go ahead and do 22. This is the one that I told you a lot of students miss because it has two terms and they're not quite sure what to do. But step 1 is always set it equal to 0 first. I have so many students that like divide by A. Don't do that. We set it equal to 0 first. So that means we need to subtract 6A from here, subtract 6A from there. Because remember, we always want to keep our squared term positive, so that leaves us with 21A squared minus 6A equals 0. So here's that two-term thing again. Remember, first we look for a GCF, then squares, then cubes. So we have to go in that order. So is there a GCF? Do 21 and 6 have anything in common? Let's see, what goes into 6? 2? No. 3? Yes. And there's an A column. common. So we're doing GCF. 3a is common. And so we divide each term by 3a. And inside we'll get 7. 2 minus 1 on the exponents, a to the first, minus, here the a's cancel, 2, equals 0. We did one like this in our notes too. So whenever we have a problem like this, remember the last step, just like up here. If a times b equals 0, either a is 0 or b is 0, and we solve the 2. So we do the same thing. If a times b equals 0, either the first number must be 0 or the second factor must be 0. So solve, divide by 3, divide by 3. 0 divided by anything is 0. Add 2, 7a equals 2. So it looks like 2/7. So then we come over here and we write 0 and 2/7. And we know that there has to be 2 solutions because this is a second degree equation and I have 2 solutions. Do you know how many students write 1? They don't set this one equal to 0. Have to set both things equal to 0 because the first factor could be 0 or the second. So 0 is the first solution, 2/7 the second. So that means that parabola is really, really, really skinny. It crosses at 0 and 2/7, which are right next to each other on the x-axis. This one didn't ask us to write it as an x-intercept. It just said solve. 20, 22, and 23 just said solve. So that means they only wanted this when they say solve. This one said write your answer as ordered pairs. That's why we went the extra step. Wanted the x-intercepts. It didn't just want the solutions. So those are the solutions. Those are the x-intercepts. This is a solution. 23 is definitely the harder of the 4 problems. So it's not set equal to 0. It has parentheses. The leading coefficient's not 1. So there's all kinds of things wrong with it. So what we do first is we have to get rid of the parentheses because we can't subtract the 5 until the parentheses are gone. So we get 4x squared plus 17x. Now we can do minus 15, minus 15, minus 15. Now we'll have 0 on the right-hand side because remember, step 1, set equal to 0. Well, you can't have parentheses and set it equal to 0. So we distribute out the parentheses, subtract the 15. Always do the opposite when you're crossing the equal sign. And now we have AC method because there's nothing common. So we have to multiply. So factors of 60 that subtract to 15. And I remember this from a previous problem, so I'm just going to write it down. We would have started with 1 and 60. No, that doesn't work. 2 and 30. No, but 3 and 20. Bingo! That subtracts to 17. This says the signs will be different. This says the largest one is plus. So go over here and make the larger number plus, the smaller one minus. So now we're going to take this out and replace it with these two. So minus 3x, remember list your negative first, plus 20x minus 15. And if you didn't list your negative first, that's okay. You'll still get the right answer, but it just prevents you from having a negative GCF. So x is common here. So we take an x out of there and we have 4x. Take an x out of there, we have 3. Bring down this sign. Next GCF is 5. So 20 divided by 5 is 4x. 15 divided by 5 is 3. And I could put those in. So x, divide by 5, divide by 5, just so you have your work there so you know where it came from. And the common binomial is 4x minus 3, so you pull that out. Remember, AC requires 3